Number 7. X cubed minus 18x minus 8 equals 0. The first thing you should notice is that certain degrees are missing. I need a 0x squared to make sure that all of my exponents from the highest down to a constant are represented. 3, 2, 1, none. Now that that's possible, I can list the rational roots. I need the factors of negative 8 over the factors of 1, so I only need to look at negative 8. Plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. And that would be choice D. Now I'll use synthetic division to test these to see if any of these are actually zeros. I'll start with 1. I put my coefficients 1, 0, negative 18, and negative 8. That 0 needs to be there to keep your alignment right. You drop down the 1, then you multiply. 1 times 1 is 1, add we get 1. 1 times 1 is 1, add we get negative 17. 1 times negative 17 is negative 17, add we get negative 25. Since this is not 0, this is not a rational root. Now I'll test minus 1. Repeating the process, 1, 0, minus 18, and minus 8. Dropping down 1, multiply negative 1 times 1, negative 1, add negative 1. Negative 1 times negative 1, positive 1, add negative 17. Negative 1 times 17, 17, add 9, remainder 9, therefore negative 1 is not a root. Next I'll test 2. Outside is 2, inside 1, 0, negative 18, negative 8. Dropping down the 1, multiplying 1 times 2, adding 2, 2 times 2, 4, adding negative 14, 2 times negative 14, negative 28, adding negative 36. Since this is not a 0, this is not a root. Negative 2. Negative 2 is on the outside. 1, 0, negative 18, negative 8. Drop the 1. Multiply. Negative 2 times 1, negative 2. Add, get negative 2. Negative 2 times negative 2, positive 4. Add, negative 14. Negative 2 times negative 2, positive 28. Add 20. Again, not 0. That is not a root. So I've tested positive and negative 1 and positive and negative 2. And I know that none of those resulted in a remainder of 0, therefore none of them were rational roots. So I will continue with the 4. 4 on the outside, 1, 0, minus 18, and minus 8. Drop the 1 and multiply. 4 times 1 is 4. Add, I get 4. 4 times 4 is 16. Add, I get negative 2. 4 times negative 2 is negative 8. Add, I get negative 16. That's not going to give me a remainder of 0, so therefore 4 is not a root. Now I will try negative 4. Negative 4 on the outside, 1, 0, negative 18, negative 8 on the inside. Drop the 1, and multiply. Negative 4 times 1 is negative 4. 0 and negative 4 make negative 4. Negative 4 times negative 4 is positive 16. Negative 18 and 16 is negative 2. Negative 4 times negative 2 is positive 8. Negative 8 and positive 8 is 0. Therefore, negative 4 is a rational root. Now I have an option. I can test 8 and negative 8 to see if either of those will work, or I could take a look at my reduced exponent polynomial. Since we started with the cube, this is now x squared minus 4x minus 2. So x squared minus 4x minus 2. And I'm looking to see if this has any rational roots. At this point, I want to use the quadratic formula. I could try factoring, but look, there are no factors of negative 2 that'll give me a negative 4. That tells me that these 8s aren't going to work. I mean, you can go ahead and do 8 and negative 8, but neither of them is going to have a 0 remainder. So I'll apply the quadratic formula. X is the opposite of b, plus and minus square root, b squared minus 4ac, and all of that is over 2 times a. So the opposite of b would be a positive 4, plus and minus the square root, 16, minus 4 times 1 times negative 2. And all of that is over 2 times 1. Remember that a is this coefficient, the one in front of the x squared, b is in front of x, negative 4, and c is the constant, negative 2. So all that's left to do here is to simplify this as much as I can. So inside the radical, be very careful. This is a minus 4 and a minus 2. That's going to make a plus. So that's going to be 16 plus 8 is 24. And all of this is over 2. Now this is not considered reduced because within the root 24 there is a perfect square. So I need to reduce this all the way. So that's going to be 4 plus and minus the square root of 4 times 6, and all of this is over 2. So that's 4 plus or minus 2 square root of 6 over 2. Here's where you have to be really careful. If you cancel out those 2's, you will miss this. This 2 denominator is a common denominator that belongs to both. That's why we say all over 2a. So it's 4 over 2 plus and minus 2 square root of 6 over 2. And now I can reduce it to my final answer, which is going to be 2 plus or minus the square root of 6. 2 goes into 4 and leaves a 2, and this 2 can divide with this 2 to leave a 1, and that's why I have a square root of 6. So looking back way up here, remember originally we found negative 4 as one of our roots. So our solution set is negative 4, 2 plus the square root of 6, and 2 minus the square root of 6.